Alright, and how's it going, everybody? So today I'm going to be showing you how to create mods for enemy behavior in Hollow Knight Silksong. I wanted to create a mod for the boss 4th chorus over here, and I wanted to walk you through my process because the logic for modifying a enemy or a boss is a little bit more complex than just basic modding for Silksong, and I wanted to kind of take you through that process here. So first let's talk about what we're going to be changing. So you can see with this particular boss, he's really not that threatening. A lot of his attacks are pretty slow, and he's also, just very telegraphed. Like some of his slam attacks that you'll see here don't even always target you. So for example, well, that one actually targeted me, but let's see if he does it again here. Well, that one did also target me, but that's fine. Let's see if we can get him to do the non-target attack here. Not quite. Yeah, there you go. You see, so his attack didn't actually target where I was standing. It just, attacked off in the distance there. And so what I want to do is I want to make it so that he is a lot more threatening. So that's going to be our main goal for the day. So let's see what we can do about this. Alright, so in order to mod enemy behavior here, what we're going to need is a tool called FSM Express. And so what is this? This is something that allows us to view the finite state machines that exist within Hollow Knight Silksong. And I guess the next question is, what is a finite state machine? So a finite state machine is basically these kind of like webbed models that allow you to understand what state an enemy is in, what state can it go into from its given state, how does it transition to different states. It basically controls how the boss transitions from each individual state that it's in and how it chooses what to do next. So in order to download this, you can come to the link. I'll attach a link to this in the description. I'm not affiliated with them at all. It's just the only tool that exists for the cause right now. And you're going to come back down to the downloads here and just download the zip file here. Okay, so once you have the application downloaded, what you're going to want to do is open it up and you'll see a window that looks like this. And it's a pretty simple application, but I'll still walk you through how to get everything configured correctly. So the first thing you're going to want to do is you're going to go up to the top here and click config, and you're going to want to change your game path to the Silksong data folder. So by default, that's going to be in C, Program Files 86, Steam, Steam Apps, Common, Hollow Knight Silksong, and then Hollow Knight Silksong data. So from here, once you have this configured correctly, you're going to go to File and then Open Catalog, and then you'll see at the top it says Loaded Catalog. That means that everything is good to go. And then from there, you can go File, Open, and then you'll see here it's going to give you all of the different bundles that are listed in the data folder. Now, these bundles are not the finite state machines by themselves. The finite state machines exist within the bundles, and not all of the bundles even have finite state machines in them. So it's a little bit tricky to figure out what bundle has the particular finite state machine that you're trying to modify. And there's not any really good assets to figure that out quite yet. But one of the ones that's pretty okay, we'll say, is this one, which is called all the FSMs.txt, which is basically a dump of every single finite state machine in the game into a text file, and it has the corresponding bundle that it's a part of. So how can we use this to actually find what we're looking for? If we go into the script for the game, if you've already done this step, which I highly recommend, there's a couple good tutorials that you can use to figure out how to pull the references from the game data. If we go into the assembly C# and then go to the player data class, which is pretty low down here apparently. Player data. Where are we? Here we are. So if we go to the player data here, you can see I already had it open. Just wanted to show you where it comes from. Then there's this field called encountered. And encountered is really nice because almost every single boss, if not every single boss in the game, has a flag that is changed when you've seen it for the first time, because when you encounter it later on, it might have a different intro, or it might not do a certain thing, or something might happen in a different way. And so this flag tracks that. And so what you can do is you can use the encountered thing to look through this file and see all the different names for the bosses inside of the code. So you can see Splinter Queen, Coral Drillers, Skull King. These don't all map one-to-one with the names as you'd expect them to be. And so you kind of have to infer what they probably are referring to, and not all of them are as easy. Some of them are super simple, like obviously Moss Mother is Moss Mother. Bone Town boss, I'm pretty sure this is the that skull dude. I forget its name right now. Belbeast is pretty straightforward. Lace 1. And then here, there's this one called Song Golem. And as you can imagine, this is the fourth chorus boss. And so once you find this Song Golem or whatever kind of boss you're looking for, then if you go back to that text file that I just showed, you can go here and type in Song Golem, and you'll see this same encountered Song Golem string. And then what you can do from here, if you scroll up to the top of the section, you'll be able to find what bundle it's a part of by just scrolling up. And you can see here, Bone East 08 boss column.bundle. This is the bundle that has this particular boss inside of it. So we can just go back to the finite state machine viewer, and if we go to Bone East, and if we scroll down to 8, you can see here, boss column bundle. This is the one that we're going to want. So we can open this up, and you can see once we open it, there are 4 different finite state machines inside of here. Now, the one that we want for modifying the enemy behavior is always going to be called control. This is a pattern that Team Cherry uses in this situation, so this is always going to be the one that you're looking for. There's sometimes going to be other ones that have control in the name, but it's not just control. Like here it says phase control, and this actually controls the transition periods between the different phases of the fourth chorus boss. But this is the one that actually controls, what it does, what attacks it has, all these kind of things. So we'll hit OK here, we'll pop it open, and you can see here is our finite state machine for the fourth chorus boss. Now, this is a little bit intimidating to look at. There's a lot going on here if you haven't seen one of these before, but I'm going to do my best to kind of walk you through the steps that are necessary to understand how to read this and how to work with it. So let's start off at the top. All of the different finite state machines are going to start off with a init if they're handling any kind of enemy behavior. So a init is going to be the entry point. It's the one that's going to be outlined in yellow. And so what's going to happen here is the boss is going to start in this particular state. And I guess let's actually take a step back and talk about the terminology here. So this entire thing is the finite state machine. All of these little boxes are the states that the boss or the enemy can be in at any given time. And then these pieces of information over here are called the actions. And we'll look at this more in a little bit. For now, let's just look at the different states. So in this init state, once the state finishes, there's an arrow, and the arrow is the transition to the next state. So once everything is initialized, then there is this meet state. So the meet state is just a condition. You can see here it's checking the player data bool test. And it's checking this encounter song golem boolean that we were just looking at, right? That was this one here. And so you can kind of see how the code and these finite state machines interact with each other in order to, have certain behaviors occur. In this case, if the encounter song golem variable is true, then we go to the, if it's true, we actually go to remeet because we've already seen it before. And if it's not true, we haven't seen it before, then we go to meet. So there's 2 different roar states that the fourth chorus boss will be in, depending on whether or not we've seen it before. Now, I'm not going to go through the entire finite state machine here, but I do want to focus on one other part, which is going to be very integral to any finite state machine for an enemy behavior that you take a look at, which is idle. So idle is effectively the central hub of any finite state machine that has to do with enemy behavior. As far as I've seen, every single one of them will have idle, and that will basically be the thing that everything loops back on. You can see most of the arrows are going into idle because once they finish whatever it's doing, whether that's finishing a particular attack, they all go back to idle. If the boss gets stunned, once the stun is over, it goes back to idle. Once it finishes its initialization for the first time, it goes to idle. Right? It always loops back on idle. So this is kind of like the central point that you should take a look at when you're trying to see how the boss behaves. And then from here, we can see that there's 4 different P states that it has, a P1, P2, P3, and P4. And so in this particular case, now this is not the same for every boss, but in this case, you can see that it has this idle state, and then it goes to a phase check state. And then depending on what phase it's in, it'll go to one of these 4 states. And so these 4 states basically dictate what moves the boss is able to use in this particular state. So you can see in P1, it has aim slam, it has random slam, and it has any swipe. And then in P2, it has the same 3 as well as coal barrage. And then same for phase 3, And then in phase 4, it actually loses coal barrage, but that actually makes sense if you remember in the fight, those like wind things that happen on both of the sides show up, and you can float above the boss. So it makes sense that it cannot do the coal barrage attack anymore. And so we can see that on each of these different phases, it has the ability to pick one of these different moves, and it picks them with this send random event action, which again we will talk about in a little bit. And then let's just follow one of them, for example. Let's say that it chooses any swipe. And then from any swipe, it will then choose specifically left swipe or right swipe. It'll pick one of these directions to swipe in, and then it'll do the swipe attack, and then it'll go back to the idle state to eventually pick another move. And then this machine will continue to migrate and transition between the states until either you kill it or it kills you, right? So now that we have a basic understanding of what's happening here, how do we actually modify these things? Well, the first thing that we need to do before we get into modifications is really make sure that we understand how the finite state machine is manipulating the different values that it has in order to accomplish some certain kind of goal. So, for example, one of the things that I said I wanted to do was I wanted to make the fourth chorus faster. And so what we can do is we can decrease the amount of time that it waits between attacks. And you can see in the idle state that we're in right now, there's this list of actions on the side here. And one of these actions is called wait, right? And so if we were to modify this time value on wait from a value of 2.5 to a lower time, say 1.0 or 0.5, something like that, then you would think that that would decrease the amount of time it waits. Therefore, it would attack, more quickly between each attack. But that's not actually how it works. And the reason is because if we follow the logic of the state machine, it goes from idle, and then it goes to phase check, and then it picks one of these 4 phases. And then if you see in P1, what happens inside of this is that there is a set float value action that is present here. And what this does is it looks for the idle time action inside of the idle state, and it modifies it to 1.0f, which means that inside of phase 1, it doesn't have a 2.5 second wait time, it actually has a 1 second wait time. And if we look at P2, we can see that it has a 0.8 second wait time. And then in 3, it has a 0.6 second wait time. And then in phase 4, it actually increases to a 0.9. And so why that's important is because we need to understand that this value, changing this, isn't actually going to be what modifies the wait time. It's actually going to be changing this value, this 1.0f. So if we change this to like 0.5 or 0.1 or something like that, that would actually make it so that within phase 1, it would attack much faster between each attack, and not changing this value here, this 2.5. So now that we have a basic understanding of why it's important to kind of follow the full logic of the finite state machine before we start modifying it, how do we actually modify it, right? Let's say that we have an idea that we want to do here. One of the other things that we talked about was like this finite state machine. It has this aim slam, it has random slam, and it has any swipe. So random slam does not actually target the player, as it implies by the name. It just randomly slams a part of the stage, which is not very interesting, right? We would rather the boss actually target the player instead of just randomly attack a spot. And so we want to do 2 different things here. First, we're going to try to get rid of random slam, and then we're going to try to make the wait time in the phase faster so that it will, basically wait for less time, therefore it's attacking more often. So those are the 2 modifications that we're going to try to make. So both of these changes are going to be made to phase 1 itself, right? This particular state. So what we need to do is we need to access the state P1, and then we need to modify the different actions inside of it so that we can do that. So let's start off by just trying to modify the wait time between the different phases. So coming to our code here, you can see that we have the kind of boilerplate for any kind of Hollow Knight or Hollow Knight Silksong mod. So I'm not going to go over this too much. I guess I'll quickly kind of explain. We have the Beppin plugin, which is just defining what our Harmony ID is, what our mod name is, and what our version is. All of this is modifiable to your liking. Then these are just a couple of static variables that we have to just like redefine them so that we can use them in our code whenever we want to. And then finally, we have a awake method, which is just initializing some values. This patch all thing is the only thing that's actually required because that's going to be the thing that allows whatever we have in our mod to actually be executed. Okay, so what do we actually need to do here? So the first thing that we need to do is we need to create a patch for the Playmaker FSM class, because that's going to be what actually handles the modification to the different finite state machines that we want to change. So we're going to do a harmony patch on the type of the Playmaker FSM. And then we are going to modify the method awake. So we are going to create a class to house all of our methods. So we're just going to do a private static class Playmaker FSM patch. The class name does not actually matter, but the method name is going to matter. So we're going to create a method here called private static void postfix. It's a capital P lowercase f. It does need to be that exact capitalization. And then inside of here, we're just going to do a Playmaker FSM, and we are going to pass in the instance of the particular finite state machine that we're looking at. Okay, so what are we actually looking at here? So on 26, what we have here is a initialization of a Playmaker FSM awake method. So we're going to be modifying the awake method on every single Playmaker FSM object that shows up in the scene. So that's not actually what we want to do, right? We don't want to change all of them. We want to change a specific one. So inside of our postfix, we're going to have to actually hone in on a specific one, which I'll show you how to do in a little bit. But right now, this is going to modify any method, any awake method that is, within a Playmaker FSM class. So inside of the postfix, what we're going to do here is we are going to first lock in to the specific finite state machine for the fourth chorus boss. So how do we do that? Well, the first thing that we need to do is we need to find the game object that is connected to the particular instance that we're looking at. So what we can say here is the owner is going to be equal to the instance, do a null check there, dot game object. Now, we want to first check if it's null, because we do want to be null safe in this, because if you don't, then you can get crashes, and we don't want to do that, obviously. So we're going to say if it's null, then we just return, we don't do anything else. But if it's not null, then we want to do two specific checks. The first check that we want to do is we want to check to see if the name of the game object is equal to the one that we're expecting to modify. So how do we know what game object we're going to be modifying? Well, if we come back to the finite state machine, you'll see here in the control finite state machine, the song golem, that's the name of the object. So what we're going to do is we're going to come back here. We're going to say if the owners.name.starts with song underscore golem, then we can add a string comparison just to do the case. And the reason that we would want to do that, then we return. The reason that we're doing this ordinal ignore case is because depending on how it's written in the code, even if it has the same name, it might be a capital S or capital G or whatever. You just want to make sure that you're not hitting one of those random cases there. So we just want to check the base name without the without the capitalization coming into play. So we have the name of the object, but then a specific object like the fourth chorus boss might have multiple finite state machines. And in fact, we actually know that the fourth chorus does have multiple because we saw that earlier on, right? It had not only the control, but it also had the phase control. So we want to make sure that we are actually manipulating the correct finite state machine. So the second condition that we want to do is if the string.equals, we're going to check the instance of the FSM name, and we are going to see if it is equal to control. Because if it is equal to control, again, we can do this ignore case, then we know that we're manipulating the right one, and if it's not, then we're not manipulating the right one. So our two checks are checking that we're modifying the right game object, and we're modifying the correct state machine within that particular object. So once we've gotten past both of those checks, we know that we're in the right place. And now that we know that we're in the right place, what do we do from here? Well, again, our goal is to go to the state P1, and we're going to make those two changes. One of them is going to be decreasing the time between the attack, and the second one is going to be changing the abilities that it has access to in phase 1. So let's start off by coming back over here, and we're going to first get the particular state that we want. So we're going to say var state is equal to instance.fsm.getState. And then here we're going to specify the name of the state that we want to get. And in this particular case, we know it's called P1. Now, in this case, we are very sure that P1 exists as a state, but generally speaking, and I'm going to do it just so that you guys do some good practice at home, we will be checking if it's null. And if it is null, then let's just log a warning saying that, hey, there's an issue, right? So there was no state named P1, something like this. That way we have a, we're not crashing the game, and we're also logging the fact that, we didn't find the particular state that we thought that was going to be there. Again, in this situation, we know for sure that P1 is going to be there, but it's good practice to get into that habit so that you're not crashing the game and trying to deal with why is the game not running correctly and all that kind of stuff. Okay, so now we have the state. And so now that we're in the state, we need to get the actions within the state. Now, these actions are in a list. There's a list variable called actions, and they're listed in the order that they're presented here. So the first item in the list is this set float value parameter, and the second one is the sand random event parameter. So in order to modify the first one, the set float value, we can just index to the first action, which would work. But I'm going to show you a little bit more of a structured way of doing it instead, because I think it's going to be a little bit better. So what we're going to do here is we're going to use a link statement, and we're going to say var set float action is equal to the state.actions.type of set float value first or default. Okay, so what are we saying here? What we're doing is we're trying to get the first instance of this set float value the set float value action within the state so that we can manipulate it in some kind of way. So this is saying that we are going to get the first set float value parameter that's there. Now, something that could happen is it's very possible, and in some situations even likely, that there could be multiple actions with the same name. And so what we want to do is we want to make sure that we're getting the right one, right? So one way that we can see an example of this is if we go to init, you can see that there's many actions called find child, and they're all finding different children which have different values on them. And so what we want to do is we want to make sure that if there are multiple, we're getting the right one. So how do we do that? What we can do is inside of first or default, we can just say, some temp parameter called a, and then we can say a dot, and then we can check a particular variable on this thing. So we can say a.float variable.name is equal to idle time. So now what we're doing, if we come back over here, is we're checking if the idle time variable is the one that is named on the particular set float value that we're looking at. So if there was two set float values and one was modifying idle time and one was modifying something else, we know it's going to be locked in on this one because it's modifying the one that we are specifying by the name idle time. So now that we have the set float action, we're basically done because this is the specific action variable. So for example, if we want to modify the float value on this particular action, all we have to do now is just say set float action dot float value, and now we can change it to something else. So we can say, for example, 0.1f. And this is all we have to do. So we've now created a mod that will take the, I guess we start off with the instance of the finite state machine. We check and confirm if it's the correct one. Once we've confirmed that it is, we get the state. And then once we get the state, we get the particular action, and then we modify the action to whatever value we want. In this case, we're modifying the float value from 1.0 to 0.1. So it should be quite a bit more noticeable that the boss is attacking faster. Let's take a look at what that's going to look like. So I'll show you guys how to do this once here. So once you've created a build here, you want to go into your Explorer. And inside of here, you're going to go into your bin, debug, and you're going to scroll until you find your DLL file that was generated from the the name of the class that you just created. So Silksong test mod in this case, and then you're going to place it into the plugins. Sorry, where is this? Into the plugins folder here. So inside of your Hollow Knight Silksong directory, again, you do need BepInEx to do this and set this up correctly. So inside of your BepInEx folder that you've created, you're going to go into plugins, and then you're going to paste it here. Now, you'll see I do have another mod here called God Home, and this is going to allow us to teleport to the 4th chorus boss, so I don't have to have a save that's set up at that exact location, which is fantastic. And so now let's take a look at the boss and see if we notice any differences. Alright, so we're loaded in here, and we're taking a look at the boss. Now you can see the platforms are gone again because the boss has been reset from the God Home mod. And so now we should see him attacking quite a bit faster than before. Let's take a look. So the first time is going to be the 2.5 second wait before he jumps into phase 1. And yeah, you can see his attack is definitely happening faster than before. Yeah. This is awesome. But you do see still some of the same issue that we had before, right? Like his slams are not always targeting me. Like right now, he's attacking that other side over there, and you know, we'll see what he does here. Oh, that was a targeted slam, nice. But you know, instead of it just being by chance, we want it to be consistently targeting us every single time. So let's do that change as well. Okay, so we're back to the code now, and let's actually take another look at the FSM Express. So the FSM Express has this other action called send random event v4, and this dictates what attack the 4th chorus is going to use at any given time. So there are the 3 attack options that it has, which are aim slam, any swipe, and random slam. And then there are these weights, which you can think of as effectively the probability that any of these attacks are going to occur. So basically, the way that you can calculate this is you add up all of the weights, and then the one that you're looking at, so for example 0.5, over the total amount is what the probability actually is. So for example, 0.5 plus 1 plus 0.5 is a total of 2. And so 0.5 divided by 2 is 1/4. So aim slam has 1/4 or 25% chance of being triggered by default here. And then the any swipe has a 1/2, so 50-50 chance. And then finally the random slam has that last 25% chance of being chosen. Now I'll kind of briefly touch on these as well. The event max basically means this many usages of that particular move can happen in a row before you have to do something else. So aim slam can trigger at most once in a row. The any swipe can occur at most twice in a row. And then random slam can go at most once in a row before something else needs to be chosen. Missed max is kind of the opposite. So this is saying that if 4 attacks have occurred and aim slam has not been used at least once in that last 4 attacks, then the next attack is guaranteed to be aim slam. And then similarly for any swipe and random slam. So for any swipe, if there's gone 2 attacks without a swipe, it will use the swipe guaranteed. And then random slam, if there's been 4 attacks without it, then it'll be guaranteed for that one. So now that we understand how this table reads, how do we actually manipulate it? Well, fortunately, that is basically just as easy as what we just did for the setting of the float value. So what we can say here is var, we'll call this SRE action for the send random event action. And then we're going to set this equal to state.actions.of type send random event. We're going to go to the v4 version dot first or default. Now you'll notice that we did specifically the v4 version, and that needs to match with the exact name of the action. If you don't use the right name, then it will not work. So you have to make sure that you're using the correct action type. And then again, if we wanted to specify a specific type of send random event action because there was more than one of them, then we could, for example, check if the name of the first event was called aim slam or something like that, just to make sure that we're looking at the right one. But in this case, you know, we know that we're at the right place here. So how do we actually modify the actions? Well, this is an array, so we're going to just pass in a new array instead. So what we can say is SRE action dot weights, because we want to modify the weights to change the values. And what we're going to do here is we're going to say new, this is a FSM float array. So we're going to say FSM float. Actually, this is a length of 3. And then here we can specify 3 values. And the way that this reads is, I'll kind of slide this down here. So the 3 values for these 3 weights are going to be replaced here. So as it's written right now, this is effectively looking like this. It's 0.5f, 1, and then 0.5f. This is what it is right now. And so these are the different probabilities for the attacks. Now what we could do is we can get rid of random slam by basically just turning the value to 0, right? Because if the value is 0, then it will have no probability of being chosen between the other options that are there. And then similarly, if we were to modify these other ones, because now there's basically a 1 over 1.5, which is 66% chance that it's going to use the swipe. So like if we move the aim slam up to 1 as well, then now it's 50-50 between using aim slam only and aim swipe. Or not aim swipe, but any swipe. But what we're going to do here is we're actually going to do something a little bit more interesting, which is we're going to kind of make the 4th course into this like bug squashing kind of thing. And so the idea that I thought would be kind of interesting is we're going to make it so that the only move that 4th course uses is the aim slam. And so by only using aim slam and by having a very short timer of 0.1 seconds per action, we've effectively made it so it's going to crush the platforms continually and then, basically give Hornet no space to maneuver around in. And I think that this will be an interesting kind of concept for the boss. So this is what we're going to do, and we're going to take a look at this. We're going to build it up again, and I will see you guys over in the run in a moment. All right, so we're back in the game here. You can see now what we're expecting from this boss is that it's going to only use aim slam. So every time it slams, it's going to target where we are, and it's going to be attacking very quickly. So basically, we should be very quickly running out of space to maneuver around the area. So let's see what happens. The first attack will take, 0.1 seconds. So, okay. Yeah, it is definitely working. Okay, we've got nowhere to be. Yeah, this is definitely working. So you can see it has definitely changed the structure of this fight quite a bit, because we are very low on options here, which is kind of sick. So I think what I want to do for this boss, all right, let me stop. So I think what I want to do for this boss is I'm going to continue to expand on it here, but I think that this is a good stopping point for this particular tutorial. And so I think this is kind of the crux of how we manipulate the finite state machines to achieve some kind of mod for their behavior. So let me just kind of rehash what we just went over, and then we'll wrap up here. So basically, in order to do it, the first thing you need to do is find the correct finite state machine. Once you have the finite state machine, you need to look it over, understand how it works, and then find the states that you want to modify. Once you find those particular states, you're going to want to come into the code. You're going to isolate that state by excluding everything that's not the particular game object and state that you're looking for. You're going to get that particular state on the correct finite state machine that you're trying to access, and then you just modify the values as you see fit. Now, there's more complex things that you can do, like you can add additional states and then transition to those ones, and create a bunch of different like modes for the boss to be, or manipulate different elements of the boss in different ways. So there's a lot of things that you can do here, but this is kind of the foundational stuff to get you guys started, and I'm super excited to see what you guys end up making. Look out for my lost 4th chorus boss pretty soon. Anyway, that is it for me. I will see you guys. I hope you found this informative. If you have any comments, just leave them in the comments. And yeah, hope you guys really enjoyed it. Like and subscribe. Peace.